All right, we'll get started. Can everyone hear me? I just see a thumbs up if you guys can hear me all right. Awesome. All right, well, good afternoon, everyone. My name is Lauren Smith, and I'm the Communications and Engagement Coordinator with SSRIA. Before we get started, I would like to recognize that as an important act of reconciliation and gratitude, I'd like to take this moment to acknowledge that SSRIA operates across Alberta, which is comprised of Treaty 6, Treaty 7, and Treaty 8 territory, the traditional lands of First Nations and Métis people. We acknowledge the many First Nations, Métis, and Inuit who have lived on and cared for these lands for generations. SSRIA is a not-for-profit organization that is taking a collaborative, industry-led approach to reducing carbon in the built environment by accelerating the adoption of innovative low-carbon solutions. We are currently funding 16 demonstration projects across Alberta and are actively sharing these results of those projects through the Building Innovation Reference Center, which is a searchable database of rich information that is live on our website. We host these project webinars for a more in-depth look at our projects, and our next one will be taking place at the same time as today's on November 17th. If you have any further questions about SSRIA and what we do, feel free to drop a question into the inbox at any time during this presentation, or you can reach out directly to Pamela Gertson, who is in this chat as well, by email, and her email is pam@ssria.ca. Today, we are going to be featuring our GBTN project with Ecosynergy. Ecosynergy is a leader in the energy performance industry, and they work with homeowners and home builders to create customized plans through sustainable building for highly efficient homes, all while accommodating everyone's needs. Amelie Caron, a sustainability and performance specialist, has been in the industry since 2001, and we're going to be hearing from her today. Amelie is a respected voice in our community and created Ecosynergy back in 2009. She's a sustainability and building performance specialist who has been in the industry since 2001. Amelie will be highlighting the journey, timeframes, challenges, and lessons that we learn when converting an existing home without any demolition to a net zero emissions in an inner city context. We will also be talking about our projections and what we are hoping to see throughout the next 2 years of monitoring. So yeah, following the presentation, we will also be having a Q&A. So if you guys have any questions, be sure to save them till the end and we'll hope to get to them. And I believe, Amelie, you are here?
Yes, hi.
Perfect, awesome, perfect timing. All right.
Thank you for covering.
Of course. Awesome, so Amelie, I'm gonna let you share your screen.
I don't have anything to share.
Oh, well then, you can go ahead and the floor is yours. And yeah, take it away.
So apologies for this. I wasn't made aware until a few days ago that we had this interview today, so I don't have any PowerPoint, but I mean, I could explain our process, what happened, what we did, and the outcome we're expecting if that works for all of you.
I think that works great, Amelie, and then we can just have a discussion and get into some questions. The other piece too, if you want, because we have some really fantastic videos that you've shared, if you want to kick off with either the video on air barrier or geothermal, I can certainly bring those up too if you'd like.
Well, I mean, I do have a presentation. It's not quite ready, but so we could, if you want to pull up the videos, I can prompt them and then you can let everybody view them. The last piece is coming soon, but the more important ones are already on our YouTube channel. So let me walk everybody a little bit through what we've done, how we finance it, all that good stuff. So getting a house for me has been quite the quest. Some may know that owning a company and applying for mortgages are, you know, two very different things, and they get challenging. So this was like a 4-year quest to be able to just qualify for mortgage, find all the money we needed to show and satisfy the banks. So in June of 2021 is when we finally were able to qualify. We looked at about 85 different houses and 8 fit the bill, and 4 were perfect, meaning we were actually including the fact that we have 2 teenagers, 2 adults living in the same space. That alone has its own challenges. So we really had a limited amount of options as far as what we wanted to do. The initial project was to build a new home and do this same strategy. And then when we revisited it, when we finally qualified for mortgage, then the pricing had gone up so much just because of all the shortages and the price of wood and all those things. So in the end, we just redirected at doing what we wanted to do with an existing home. So we finally bought the one in Windhaven, which is the one that's showcased everywhere. And so during this whole process, we had to educate the realtor and the mortgage broker as to what we wanted to do. Obviously, educating the realtor was a big deal because just by looking at the house from Google Maps, a lot of those houses kind of got neutralized. Either we didn't have access to the yard, we didn't have a yard big enough, we didn't have proper roof pitches, we didn't have optimal floor systems. There was so many things that we needed to check before we could sign off the conditions. And interestingly enough, we did put on our conditions to buy the house that we had to be able to verify that it could meet net zero energy. So it was actually on our contract agreement, which is kind of cool. I don't know if the other owners knew what that meant, but in the end, we finally got the house that was working for us. The mortgage broker was also a really good trooper in this whole thing. It's not something that they necessarily, not that they don't understand it, but usually when we do a financing on a mortgage, that is, there's a Reno Plus piece that's attached to that. So that's how we were able to fund a big portion of the ground loop system. They usually go for renovations that are mainly aesthetic. So, layout, finishings, extensions, that type of thing. And so they actually had to build a case to the appraisers, and we helped them do that, kind of explaining where the building codes were going, why we wanted to do it, the value that comes behind it, like 10 years down the road, which is pretty short term when we talk real estate. And so we educated the mortgage broker to this aspects of the project, and then he had to relay that to the lenders, the insurers, and the banks as well. So in the end, we succeeded. It worked out. There was a couple hiccups along the way, simply because usually when we do a Reno Plus mortgage application, the scope of the renovation has to be done within about 3 months. Well, needless to say, we signed the house in August. 3 months later would lead into mid-fall. Drilling costs go up, limitations and availability of equipment, because apparently all the drilling rigs go north in winter. I guess it's because the ground's frozen and they can only do it in that time of the year. So we were running out of options. So we were able to successfully negotiate not an extension, but let them know that we would try to get this done as soon as we could, and the grounds thawed. And they were actually really good to us. They worked with us, and we were just keeping them posted that yes, the project's ongoing. We're aiming for this date. Oh, the date got pushed, but it's coming along. And so we were able to start the scope in April. In the end of April, I believe. So it was about 6 months out, and anyways, everybody was on board. And I think they were kind of just happy to be part of this. So that was the financial piece and the challenges we ran into with that. Now, the technical piece had its own other interesting facets. Drilling holes is easy. We have the best drillers in the country. They know what they're doing. What we found out is that it's all the unknowns that come with the drilling that get really interesting. So when you have an unreal amount of water that can't go on the street, inner city lot, and you're surrounded by your neighbors, or there's you hit some really hard rock during the drilling process and the neighboring houses start shaking, neighbors start asking questions. It's a big piece of equipment, so obviously the neighbors were kind of all sitting on their front porch looking at it. So, you know, I did brief everybody in the neighborhood last summer that this was going to happen, so I didn't make any enemies through this. But I feel that making sure that the neighborhood was aware of what was going on, and so we have this Facebook page for the neighborhood. I kept updates on there so owners would know that anyways, this was not going to go on forever. and so the drilling took about 2 weeks. We had a few hiccups along the way that we fixed as we move forward. And then we personally had to trench the whole yard, and we'll show you a video that kind of explains the whole process. And so all in, the ground loop took about 5 weeks of work. There was no disruption to the house. We were living in the house the whole time, and they only worked during work hours, so no late nights for any of the neighbors. Nobody complained, everything was good. And then we waited, and then the last piece of the puzzle came in this last August. So pretty much a year to date, the solar system went on the house. So the reason why we chose this approach to retrofit our house to net zero is that, I mean, I love insulation, don't get me wrong, I think we need it. But I don't like the idea of just demolishing houses that are not ready for landfill. Any house that was built between 1995 and today might not need a full gut reno, right? The plumbing code's almost the same, the electrical code and the materials we use are almost the same. And so that was the bigger pieces. I was wanting to see, can we do this without any waste? And the process went well. Like now we're going to be going into the verification stage, but as of now, we were successfully able to do all the work we had in mind without any demolition, other than a 4-foot strip of drywall in the basement that we had to take down. And you'll see on the video, just to bring in the ground loop to the mechanical room. But we literally gave our old furnace away to a neighbor. And when we're ready to pull the gas fireplace out, we'll give that away as well, and we'll convert it to something else. But you know, I found there was quite a bit of satisfaction around not throwing anything out. The other piece of the puzzle was, can we get this done on 100 amp electrical entrance? Because most houses only have 100 amp electrical entrance, and upgrading that electrical entrance to a 200-ish can get very, very expensive depending on the location of the house to where the transformers are. So our property, the transformers are on our lot, so it would not be an issue. But could we get this done for other homeowners that might not have that kind of luxury? And with a lot of creative thinking, we were able to electrify the house, keep my EV with the 100 amp panel. So the education at the city and the working with the electricians and all the moving parts came in, you know, there was a steep learning curve there, but everything's working great. The outcome is really fun. I finally get to nerd out on my solar app, and all the monitoring systems should be up and running. The solar monitoring system is up and running. The full house monitoring is up and running. The indoor air quality monitoring is also working. Now we're just, I'm talking with the heat exchanger monitoring people this afternoon to hopefully get that online. So now we'll be able to not only monitor the utility costs on a month-to-month basis for the next couple years, but also monitor, you know, the generation versus consumption and the heat energy from the ground loop to the house. So what kind of, you know, energy do we actually get? Are we running into challenges? Because that's the big question. Is this going to work at minus 40 Celsius? And I'm guesstimating that it will, because I took that on and I figured we'll take a leap of faith. I am highly relying on our engineers that have done this multiple times over and they had no issues. So far so good. We are getting into the monitoring piece. I just have to refine my spreadsheet, and we will be showcasing all those results. probably by October of next year. So in the meantime, I'm just religiously just compiling all my data and see what the outcome is going to be. So what I'm hoping to showcase is threefold. One, that a ground source heat pump without secondary heating works at -40 to keep the house at proper and constant temperatures. Two, I want to see if energy-wise, we can actually make this house net zero energy, meaning that we will produce enough in the summer to offset the winter months in energy. And three, the same financial calculation. Will the financial credits of the summer offset the cost of the electricity to run the house in the winter? And if not, what's the gap? What could we do? So these are the kind of three metrics that I was monitoring. The other piece that I was asked to monitor is the peak loads. So heating load, heating peak load, and cooling peak load, because that's what insulation does for us. Is when we insulate more, we shave off those peaks, which makes it more palpable for the utility sector. So although we haven't changed anything to the shell of the house, we are kind of wondering if, because of the efficiency of the mechanical systems, if we will see or not a drop in that peak heating load. As far as the cooling load goes, from what I saw this summer, cooling my house used less energy than charging my car, because the heat pump on the ground loop is running at efficiencies that just mind-boggling. So we used very, very little energy to cool a house. So now I'm really trying to see what's going to happen in the dead of winter and see if that could be another option to tack on to the retrofitting process. So I don't know, Pam, if you would like to kind of show the videos one by one, and then maybe there's a few videos that are available to public. We have this step one, which is installing air barrier in the house. So the reason why we did air barrier in our house is, well, right now it's kind of the only technology we have to bring down airtight air leakage in a house without any demolition, as of now. And what we found is we were able to drop the heating demand, just the heating load, by about 20% just by air tightness. So we used the air barrier to do that, and the video will show the preparation, how that worked. It took about 5 hours to seal the house, from 4.5 air changes per hour to about 1.2. So that's a significant drop in air leakage. And final, as of today, I think we're closer to 1.9, because we had to do stuff in the rim joists to put all the conduits, and so we foamed that area now. So we're a little higher than 1.2, but we're far away from 4.5. So that was the energy efficiency strategy that we used on the house to try to limit the demolition that we would have to do. Step two was just doing the geothermal system, the geo exchange. And then step three is the solar install, which should come online tomorrow on our YouTube channel. So for the ones that everybody here knows what solar looks like, but if you want to see a pretty cool video that was made by a local one-woman show here in Airdrie, I find her videos are fantastic. And then on the side to that, we have two other interviews, one with the mortgage broker and one with the realtor, that kind of explains a little bit their perspective on the project and what they've learned so far. So Pam, I don't know how you want to move forward. This was a really quick, overview of what we've done. Yeah, I expect just a lot of questions is kind of what I'm.
It was a great overview, and I think it does set up an opportunity for some great questions. And I'm glad you touched on a little bit of discussion around the air barrier use. And I will bring this video up momentarily, and then maybe we can jump into some questions from there. Specific to air barrier, and then we can always go into the geothermal video as well to kind of tee up any questions that might be related to that.
I don't know if you'd like to show the mortgage piece, because that's also how we financed the project, because we didn't borrow any money at the bank really for it. So if you want to, after we're done watching this, maybe some would like to see the financial piece to it, and because that's an interesting piece for homeowners.
Yeah, it's a really interesting question, and even to hear, hear the detail that you shared about that process that you went through with your mortgage broker and all the education that was required both on that side and the realtor side. Is so interesting to see all the touch points that it's not just about a building, it's not just about a home, it's all the kind of interconnectedness of these various industries. So I'm gonna bring this up and see if, just give me a second actually, because I realize I probably have to share this with sound. So give me 1 second to redo this. And I'm assuming everyone can see the screen now.
They're finally ready to seal our existing home because we have energy targets on this home that we're hoping to showcase. But the end goal is going to be to make this house carbon neutral. So doing air barrier is the first step to our project because we would target the one big thing that could save a whole lot of energy, which is air leakage. And air barrier is the only technology as of today that can do that in a finished house without any demolition. Air barrier is an air tightness product that is it's installed with positive pressure. The blower is a big fan. These blowers can go up to about 6,000 CFMs. So by pushing or forcing air into the house, the house is going to want to blow up to the outside. And by doing so, the air in the house will try to escape because it can't stay in, it has to go somewhere. So it leaves residue when the pressure stops. We have to protect all the horizontal surfaces for deposits so that when we turn off the system, then everything falls to the ground. It doesn't damage. It could be sticky per my hands. We'll get it all off. So without major renovations or fairly disruptive renovations, air barrier is the easiest way that we know of to bring down the air leakage rate at an existing home, especially.
I'm curious, Amelie, about you talked about, you show at the very end of the video about the stickiness and the residue. I know when you went through this process, it was specific to a brand new house you had just bought. Oh, sorry. And so curious if you've applied the aero barrier or seen aero barrier applied in homes that are already occupied. If somebody that already owns this type of home that thinks they might be able to go through this process, what would that look like?
Very much the same thing, just a little bit more money. So we have actually successfully sealed multiple houses that were fully furnished. Nothing got moved out. There's a few tips and tricks that we give the homeowner just to prep the house properly. What we do then is we actually partnered up with a local group that does asbestos remediation. And so they're expert at compartmentalization with tarps and all the proper plastics or whatever they use to just kind of seal and prep everything off. So we just partnered up with them and they prep the house for us. So they know the scope of work, they know what it entails, and they go in. It's a day's work. They bring a crew of 4 or 5 people, whatever the size of the house is needed. Usually a day is sufficient to prep the house. So that's an added cost. And then the aero barrier just comes in the next day and it's the same price in a new or an existing home because it's the same scope. And then usually take down to all the preparation materials and stuff are done just after we're done sealing the house. Now, we have sealed some new houses that were just, about 10,000 square feet. So that's a little bit more prep time and a little bit more takedown time. But for the most part, you're looking at 1 day to 3 days max. So we can do it in fully finished and furnished homes. Now the price tag attached to the preparation of it will vary. Some homeowners are pretty hands-on and they're okay us sending them some pictures and they'll do all the prep themselves. And then what we do is Darren from our office just goes to the house the day prior to the seal, kind of looks at what the homeowner did. So if the homeowner is hands-on and they're willing to do the prep themselves, then they can just skip that whole prep cost. But what we've seen so far is ballpark, you almost double the price of the seal if you want a third-party professional crew to prep the house. The other thing we tell the homeowners is anything that has either a high value or a high emotional value, just take it out of the house. Like the ceiling won't damage anything. It comes out like a little bit like Post-it tacky. So it's not like glue, and it's not like it doesn't stick at all. And once it's dry, it's actually water soluble. So what you saw in the video on the floor, I just got it off with a steamer floor cleaner, right? And I still have, I did not yet clean all my window sills. Some got on there. They're white, so I don't see it. But there's still, yeah, you can see it when the sun shines. There's some matte areas and some shiny areas of window sills. I'm a year moved in, so I haven't scrubbed all my windows. But ultimately, there's no residue on the vertical surfaces, so all the walls, no residues on the ceiling. So for houses that just want to get, for example, the 10% on the Greener Homes Grant, don't bother. Usually that 10% on the Greener Homes Grant will be achieved just by changing windows or swapping your old furnace by a new one. But for the homeowners that are looking at, high performance, net zero, that kind of thing, then they might find a lot of value in doing this, because just by dropping the air leakage rate, they can reduce the rest of the renovation scope of work.
And does it seal the home to a point where like additional ventilation is required to kind of maintain a healthy space?
Yes, happy you brought that up. So I'm just seeing the chats. I'm just taking notes to answer the questions later. Yes. So the other thing we tried to do, and that was an agreement I had with my husband. I'm doing my best not to install an HRV unit. You can say, what? Your 1.2 air changes per hour. What are you doing? Well, the thing is, I'm trying to make this real for as many older homes as I can. Okay. And currently, some older homes might not have proper ductwork, might not have the room, the money to put an HRV in properly. So I'm getting away with it. Now, it's not efficient, and my electrical load is a little higher because the way I have my fans and my blower set up, it's using more power than if I was using the HRV. But what I did is I put all the bathroom fan, well, one, I replaced my fans. I put some fans that have a higher flow rate and that are much quieter, because they run a lot. And if they would be, I think 0.8 zones is kind of where I would cap the sound or the noise of the fans. 0.8 or lower, now I'm looking at about $200 a fan. So I replaced all my fans by really quiet and very powerful fans. And all the fans are hooked up on a humidity sensor that is set to whatever relative humidity I need to be set in the house, which I'm targeting 35% RH in winter, minus 20. People would say, oh, well, that's really dry. I'm like, yes, it is very dry. The thing is, because my house is not a high performance house and it's not more insulated, my windows are, let's just say the way it is, crappy double pane from 2010. That's the relative humidity that I need to keep in the house so I don't get too much condensation in my windows and I don't get mold on my walls. So if I had a passive house or highly insulated house with much better windows, then I could bring up that relative humidity to about 40, maybe even 45%, and have a different level of comfort. So because my house is built to 2010 standard, we have to keep it around 35 max at minus 20. So putting humidistats on all the exhaust fans, and then the main ventilation switch, because I have one of those, I put that on a humidistat as well. So interestingly enough, I did not know this until it started doing this on its own. When that is triggered, the main blower of the heat pump turns on, it moves all the air in the house, and then it's funny how it just triggers all the other fans. So I've been pretty successful at keeping my VOC down and my my humidity level is actually really in good check just by doing that. So the fans indirectly interlocked with the blower from the heat pump, which is, by the way, way more powerful than anything you'd see in a natural gas furnace. My moisture levels and my pollutant contents are actually really good. I did find out that I have radon in my basement, so I will be in touch to get a radon mitigation system put in the house, especially in winter, because now we're creating this stack effect because we're getting into the heating season. But I would get one of those put in so that by next summer, that is also addressed. So hopefully that answers your question.
Yeah, absolutely. And just seeing one of the questions on the chat here, and you quickly touched on the Greener Homes grant, and I'm just curious as far as incentives that were available and even the financing overall. Maybe you can talk a little bit about how this project was financed and what incentives were applied.
So other than the SSRIA support that we received for this project, I did get the $5,000 from the Greener Homes program for the ground loop. The solar was not part of the equation. We left it out. People needed to get paid. Let's just put it that way. So I had to accelerate my Greener Homes application, but I did get the full $5,000 for the ground source heat pump. As far as the rest of the financing, we were able, so the geothermal system came in at about $65,000 all in, meaning drilling, trenching, coring, bringing the lines into the house, swapping the gas appliances to the electric ones. That came in about $65,000, and that includes my time, my labor. Aero barrier would have been about $4,500 without the prep, because I did that myself. So we were looking at about, $69,000 all in. Out of that, $40,000 was paid through the mortgage, and the rest, as a homeowner, I would have had to figure that out on myself. But 25 grand line of credit or small loan is not necessarily a big deal. It's pretty palpable compared to 65 or 100 right. So that was the piece. So 2/3 was paid by the mortgage, which is kind of neat. Yeah. And then the solar, well, I just got a solar loan for it, and I did not go through the government federal loan because it means I would have to resubmit a whole bunch of stuff. And anybody that works for the Greener Homes program knows that it's a really big pain in their butt. So I just left it, and I will pay the 6% interest rate of my solar loan on 10 years rather than having a 0% on 10 years through the government. So yeah, ultimately the finances are still making sense. We estimated that in the coldest month of the year, in the darkest month of the year, including my solar loan, I should be paying the same thing in that month. So last year I paid $675 in utility, including gas and electricity, for that really heavy month. And so this year we're estimating about $250 in utilities. And if you add the solar loan of about $350, then we would almost break even in that really expensive month. But the rest of the year, that's where we save a ton. So with smart budget management, I'm not too worried about getting through winter, financially speaking.
Perfect. Maybe we'll take that quick pause, and I will play the next video, the geothermal video, and then we have maybe some additional questions that more tie into the energy use and electricity systems in the homes.
Yes.
I will just quickly tee this up and then reshare.
My name is Koen van der Maten. I am the president of Thermal Creek. We are Calgary-based geothermal heating and cooling design and installation company. When we started our business, most of our clientele was really focused, how do I reduce my gas bill? So we're very financially driven. I would say over the years that has changed a lot. A lot of people like Emily were living in existing homes and requesting a smarter way to heat and cool your home. And I understand heating and cooling very, very well, but there's other parts of the house that have nothing to do with heating and cooling that I don't understand as well as Ecosynergy does. And that's why it's great to have an industry partner there who can sort of take my information and then put all the other information together and then have a holistic picture of, well, this is what it's going to take to make this house net zero. So Emily approached us in Thermal Creek to do a geothermal retrofit for her house. Our company is going to essentially take out the old gas furnace in this house, and we're going to retrofit this house with a geothermal heating and cooling system. Challenge simply with retrofits is that there's just not a lot of access. So you need a fairly sizable rig in order to get to that sort of depth. Think of it as, I have a big RV and I need to be able to park that in my backyard.
I had city bus.
Yeah.
After we've done all of our design work and we sort of identified where we're going to drill, then it starts with drilling. So that will be the first big step. Drilling, we're going down to depth. Then after we've reached the depth, the actual drill stems get removed. We're going to install the geothermal, the prefabricated loops. They're going to go down into the borehole. And once they are down to depth, the boreholes will be grouted. Now grouting is a process. Essentially, this is a thermally enhanced type of bentonite grout that stays a little bit more elastic than, let's say, cement or so. So what it really does is it seals up the borehole well and makes sure that the loops have perfect contact with the surrounding earth. The next step will be a small header trench to ultimately connect our boreholes in a sort of a manifold type fashion outside, and we run a supply and return line into the house and then ultimately into your mechanical room, and we pressure test everything. And once we know that the pressure test is good and there is no leaks anywhere, then that trench can be backfilled, and really that field will never need any form of addressing. It's very durable.
Fantastic. I really love what Cohen touches on at the beginning and talking about you know, the opportunity to even work with you and the expertise that you brought to this project. I think it really highlights the value of you know, SSRIA's focus around collaboration, and this is really the message that I keep harping on, is that the importance of that collaboration is because there's so much different expertise in so many different areas that when we bring it together, we get to kind of solve big problems like this one has solved. So maybe with that, I'll go to Jesse's question just around energy management technology. And I had a very similar question just around really ultimately, how did you manage to keep the 100 amp service with an EV and, you know, with the electrical pull of the geothermal heat pump?
So this is the one thing that everybody was waiting on the drum roll if we'd be able to pull it off. And for the most part, we did. And the interesting thing about the geo exchange is that we don't need a secondary heating system compared to an air source heat pump. So the air source heat pump needs a breaker for the heat pump itself, and then it needs a breaker for secondary heating because in winter, the heat pump cannot generate enough heat. It shuts off. So you're running on grid electricity in the coldest month of the year. Whereas on the ground loop, no matter how cold it gets outside, at 300 feet down, or even less than that, 10 feet down, the ground is always at 4 degrees temperature. It's completely irrelevant than what's happening outside. So instead of having, you know, a 40, 50 amp breaker for the heat pump and another 50 amp breaker for secondary heating, we only needed 60. So the whole ground loop, the cooling, the heating, and the hot water runs on a 60 amp breaker. So there was quite a bit of room left in the house. And funny enough, when we bought the house, there was a hot tub, and the hot tub was on a 60 amp breaker. So we just reused the existing breaker that was there. And then we needed a 50 amp breaker for the solar, right? And then the rest was fine. Now, when we did the electrical load calculations with the electricians and the building code, and we were getting all this reviewed with the city officials and all that stuff, anyways, what happened is last year, before we started all this, I reached out to the city to ask for permits because I wanted to make this true. And I know that we were going to showcase all this. I didn't want to get into hot water. And there was a disconnect in the communication. So I asked if I needed a permit for geothermal. They said no. But what I didn't know is I needed permits for other things. So I only found out this year that I actually needed some level of permitting to do my project. So here I was, the system was working. Like I didn't have anything. I didn't have a DCC. I didn't have anything. Nothing was jumping. Everything was working just fine. Once in a while, I get my lights to go like this when my heat pump kicks in, but everything was working already. And I tested the house, I turned on the charging, I turned on the stove, I turned on the dryer, I turned on the hot water, and I turned on the heat pump, and nothing jumped. So we already knew everything was working, but the electrical codes, I think are a little outdated, like the way they calculate the loads per floor and that type of thing. Maybe there's something to be revisited because compact fluorescents are not something we see a lot anymore. The appliances have gone way more efficient than they used to be. Like everything saves electricity nowadays. And so I think that was also part of the equation. So in the end, just to appease the city, what we did is we did two things. We installed it's called a DCC, I guess it's a direct current controller or something like that, to kind of shut off the power to the garage outlet. So I drive a car that doesn't require an electrical charging station. All I need is a dryer outlet, and the car itself has its own little amperage modulating system. So what it does is it's not going to pull more energy than what the source allows it to. So never did I have to upgrade anything on my electrical panel with my car. And I've lived in houses that were, 1970s, early 80s, and I never had to do any of that. So we did install the DCC to monitor the entire electrical load of the panel board. And when we reach 80%, then it cuts off the electricity to go to that 40 amp outlet in the garage. And then it will monitor. And if after 15 minutes, like when it opens up to more than 80%, then it will stay on standby. And if it stays like that for 15 minutes, then it would allow current back or power back to the electrical outlet in the garage. And so it's basically a full panel monitoring system just to kind of reduce the risk of overloading the panel board when the car kicks in. Now, I don't even know if it ever, maybe once, when we had, let's say we were cooking or we were showering and the heating came in, then I think I saw it once kick off the charging to the car. So, I mean, it's a good safety, and I wanted to do this so that, we would future-proof the house. Different car manufacturers have different charging appliances, different loads. So now at least we future-proof the house so that no matter who would move in with an EV or not, and with any kind of EV, they would be able to use the panel board. And the other thing that we did, a small change, was that we did change the cable from the meter of the house to the electrical panel board entrance to 125. So the breaker, the bus bar on the electrical panel board was already rated for 125. And Fortis, from what I understand, most of the houses are rated for 125 amp, but the cable to the house, from the house to the meter, was a 100 amp cable. So we just upped that cable to 125 so it would handle it's a slightly larger cable, and we also changed the meter base. So that was like $2,000, no, not even, I think it was about $1,500 upgrade. The DCC was another $1,000. So all in, I had an extra $2,500 in electrical work to appease the authorities and make sure that we would future-proof the house.
Fantastic. Just I guess a few minutes left here, and I do want to invite folks. People have been putting some questions in the chat, but feel free to also unmute yourselves and ask your question if you have any questions. I'll just maybe open the floor and let folks do that right now.
I mean, Pam, if there's no questions, maybe you want to put the mortgage broker video on.
I don't have that one linked on our website right now. Is it just directly through
It's not,
yours?
if you go on our YouTube channel, on the Ecosynergy YouTube. Oh, puppy.
Maybe while I look for that, I do see that Cindy had asked a question about, you know, how can we justify the extra cost? I'm guessing this means of retrofitting existing homes to homeowners.
I thought that was in regards to aero barrier.
Oh, okay.
But if Cindy, it was another question, please feel free to just add in the comment to clarify, and we'll answer it.
That, I mean, if that is a question, then what is do you have thoughts on payback on aero barrier of what you've been seeing to date?
Sorry, I had somebody come to the door. I guess the question was, you know, again, yeah, it is. How do you justify, you know, you say it's expensive, and then also the extra cost for taping up your house. How do you justify that additional expense, or can you, or is there payback? You can't.
You can't, and that's why if they're only going for the 10% of the greener homes grant, it's not worth their time. But if they are looking at a full-on net zero energy retrofit, then there's a bigger picture, and that cost is more justified. And so we get some calls for that 10% because the Canada Greener Homes Program separated that upgrade item, which really makes no sense, but that's okay. And so we're transparent with them, and most times they don't take it. But for the ones that are either, you know, doing the greener homes on a house that was moved, for example, that was picked up and put on a foundation, and now they're renovating it, and that's the new house, then they are willing to pay that premium because it's going to get really challenging to have a good seal on a house that's made out of a whole bunch of different pieces. So in a case like that, they are willing to pay the extra cost, and they're participating in it too.
Right.
So it's not quite double, but it is a premium.
Well, I guess too, if it's your, you know, you're at the beginning stages of being in that home, and it might be your forever home, there is some peace of mind and advantage, as opposed to you being mid-cycle of a home and you might only be there for another 5 years.
Yeah, and I think the other thing to keep in mind too is if somebody is looking at changing their flooring, for example, and they're going to be moving furniture out anyways, then there's a strong possibility that there won't be any premium, because if the flooring's not in, then all we have to protect are the cabinets and the baseboards along the walls are going to be taken out. Then there's not much to protect, like the carpets upstairs maybe, but it is a case by case. So we usually screen them and see what, like, is it better that they pay us just a little bit more money to prep the house, or is it worth bringing in a full professional crew? So it's a two-way conversation on the retrofit side, just to make sure that, you know, we don't miss anything and we keep the cost down for them. But yeah, if it's just for the 10%, even 20% of the greener homes, it's not really worth the money.
It does remind me, I had a question about, I know you talked about not wanting to do any demolition in the home. But did you, what was there for like attic insulation? Was that a consideration, just to add some added insulation and kind of thermal performance on the home, or was it already at its peak ability, I suppose?
No, I could have added an extra R10. So we have R40 in the attic. We could have went to 50 or 60, but ultimately, because the attic wasn't the biggest heat loss of the house,
right,
then there wasn't any real, right? It wasn't the biggest bang for the buck.
there was no return on
the walls
that,
and windows were the bigger culprit, and those are things that we couldn't really change without demo.
Yeah.
And I mean, there was the cost coming into, and that's why I want everybody to know that I like insulation. I'm not saying don't do it. But we did get some quotes done from, because I wanted this to be real, right? So I did ask Peter Darlington to come out and give me a quote to do the exterior insulation, take off the vinyl, do the electrical upgrade, because we were going to an air source heat pump with secondary heating and attic insulation, all that stuff. So ultimately, only the exterior finish of the house would have gone to landfill, and then we could have finished with new siding. We weren't replacing the windows, but that came in, 6 figures compared to my 65. So it was just under half price. So although my house is not going to be I don't expect it to be more comfortable in winter. It is more comfortable in the summer because I have cooling now. And I don't know how much shaving we'll get on the peaks. Cost-wise, it made a lot of sense. And I mean, the other thing too is I wasn't allowed to put exterior insulation on the one side of my house because the bylaws don't allow me to do that because I'm on zero lot line. So there's some limitations. So this is an option. It's not a solution for everything. Not every lot's going to be able to do this, just like not every lot's going to be able to do exterior insulation. And I feel that that's where the conversation needs to go, is it is not a one size fits all. And even in new construction, we have to be open to the idea that it might just be a hybrid of the two. Maybe we just start building or renovating for comfort, like reducing dew points, reducing condensation, and then we use the active systems to make up that balance. Multiple reasons why diminishing return is a big one. Cost, ease of install. I mean, it's great that we can put 6 inches of exterior insulation on a house, but I only know one group that can do that, right? Like if we're going to the masses and we have millions of houses to retrofit in Canada, who's going to do this? And I mean, we have a short time frame to do it. So I'm trying to bring other perspectives just to see what other conversations could be had either at the building code development side of things or in new construction or existing or with renovation groups, like what's possible.
I think that's such an important point to make, just with regards to there's a massive number of homes that we need to address, existing homes that we need to address. And we have to stop looking for a silver bullet or a one size fits all solution. And that was really part of the reason why SSRIA was interested in this project, is we are also doing retrofit projects that are looking at the exterior insulation and the panelization. But this really provided a solution for a different subset of housing that still is, I mean, it's a newer home,
but they're not there yet
to some degree, but it's still not meeting a high performance or a really high level of performance. So a lot of opportunities in this housing style to be able to move it forward. So we're really so happy you're part of the SSRIA project team, I guess, and that we're able to showcase your solution. And yeah, I really appreciate you sharing so openly as well the learnings that you've had throughout the project. So some of those we've just seen in the video format. And as Emily has mentioned, there will be some additional videos to come. Just based on timing, I won't go to the next video, but you can find those if you go to YouTube and search Ecosynergy, but they'll also be posted to SSRIA's website in short order as well. So you'll be able to find all those on SSRIA's website under here, maybe I'll just quickly show this while I'm in the last few minutes, just so everybody can see where the heck to find this. And so if you just go to SSRIA's website under projects, you'll find the whole listing of projects. And this Ecosynergy project is called Carbon Neutral Retrofit Without Demolition. It's number 18. And then if you just scroll down here, you'll find those 2 videos currently listed. We have another resource under Resources and Reference Center, where you can search information about, based on building type, building system, or popular subjects. And those videos will then also be linked through that format as well.
So I would just like to, oh, sorry, Pam, go ahead.
No, you go ahead. I was going to close it out anyway. So
I would just like to let you know, so the last video, step 3, should be coming online tomorrow or Monday. So if you want to subscribe to our YouTube channel, you'll get notified when it's up and running. The other thing too is the videographer that did all this footage for us won a grant subsidy by TELUS Optics. And she is now working on a full-on 30-minute documentary, and we're just the subject matter. She's the producer, and this should be released on every news channel across Canada. I think it's in spring of 2023. But if you stay tuned, we'll make sure that we showcase this on our YouTube channel as well, or put the link to it, because that'll bring the whole human piece, like where we almost lost it all, where we recovered, what happened, because there's a little bit of suspense to this whole thing. So if you want to either follow us on social media or YouTube or whatever have you, this documentary will be showcased, because I can't wait to see it, because I cried a few times and it worked out. But it brings a human piece. And the last thing is, if any of you have questions, please, Pam, you're welcome to share a contact or my contact with anybody. Please reach out. We do open up our houses for the ones that want to come to Airdrie and see it, see the aftermath, see the yard and mud pies, and get the emotional side to this whole thing, because no renovation project is ever smooth. I'd like to think that this one was quite smooth, but yes, there's a human piece to any renovation project, and we're going to showcase it as well, because it keeps it real.
Yeah, for sure. And I just for everyone, I put the Ecosynergy YouTube channel link in the chat box, so that you guys can head there right now and hit subscribe, and then you'll have all those future updates. Super interesting. Thank you so much, Emily, for the information, and all those who could join us and listen in and learn today. We look forward to
Thank you for having me.
Yeah, absolutely. We look forward to seeing everyone at our next event.
Thank you, everybody.
Thank you.